still initially. Oh, now we're on. Okay, good. Okay, so the kids are all excited because we're going over the last free response topic, area and volume today. Yeah, they're psyched. And they were saying, well, so we want to make sure we know everything about area and volume that we need to know. So the first thing we're saying is that as long as A, the lower limit, is less than the upper limit. Oh, and I realized this should be an X. I don't know why that's a T. Same thing here. See, that's a good thing, right? Um, what does the definite integral give you in terms of the graph? Perfect, kids. I don't know how I did that. I didn't even draw it. Area above minus area below. Meaning that if you had a graph of the function from A to B, this is right, and the area above the x-axis, oh, I'm going to give it some numbers. Kids at home sometimes like numbers. Let's say that this area up here was 6, and that area down there was 2. If you found the definite integral, what would you get? 4, right? Like in this case, it would be 4. I'm not writing that. Okay. Now, if you have a calculator, and what you really want is the area above plus the area below, you want the area enclosed by a graph in the x-axis, what can we do to the function before we integrate? Absolute values. This is great. So it's a definite integral from A to B of the absolute value of the function. Because what that'll do is anywhere the graph is negative, it'll first reflect it over the x-axis. And then when you get the definite integral, you get all the area. So with these numbers that I put up there, what would you get if you took the definite integral from A to B? 8. Oh my goodness, these guys can add. They didn't even take out a calculator for that one. No, they could have. Okay, now let's say that you didn't have a calculator and you were asked to find the enclosed area. And let's say that this here is C. How could you... So this was a no... Yes. Okay, you have to... So I'm saying we have to do them separately. So we would take the integral from A to C. Okay, and that would get us the area of that first region. And then she said we'll do it separately. The other one will take the definite integral from C to B. Now, yeah, you want to subtract because you'll be subtracting a negative, so you'll be adding. It'd be like minus negative 2, because when you take the definite integral of a function that's all below the x-axis, the definite integral will be a negative number. So yeah, you take the definite integral wherever it's above the x-axis and subtract the definite integral where it's below. Or keep the plus, but then switch the limits of integration wherever it's negative. Okay, now, one of the big things you're going to have to do on the free response questions, usually the first part of a free response question is get the area between graphs. We have only 2 ways to get the area between 2 different graphs. We can use vertical strips. And if we use vertical strips, what do we do to get the area? Yep, you integrate the height, which will be y top, minus whatever y equals on the bottom. And what's the width always going to be with these? Dx. Nice. And you add these up from the smallest x to the greatest x. I have that written here. So where a is the least leftmost x, and b is the greatest, the rightmost x. And so you're adding up an infinite number of these rectangles, height times width, and you've got yourself all the area. The other way to get area between curves is to use horizontal strips. Sometimes that's more convenient. So let's say we wanted to get the area enclosed here, and we want to use horizontal strips to get the area. X right, so the height of each strip would be x right minus x left. Yeah, I'm calling the height the longer one, it's kind of arbitrary. And the width would be dy, which is very important because that tells you that the only variable that you can have here is a y. So even though I say x right, it's what x equals. on the right curve. But in terms of y, it's not constant. Yes, from C to D, the smallest y to the greatest y coordinate. So you go bottom to top. Real nice. That's it. When they ask you for area, if you're putting pies in there or you're doing something fancy or squaring something, alright, it's just either y top minus y bottom dx or x right minus x left dy. That's it. But we do have volume, and there are only two types of volume problems, but these get a little bit more complicated, but not much. You have solids of revolution. Those are solids that are created when you revolve a region about a line. Now, you can revolve the region that's attached to the axis of rotation, and each slice is going to be a disk. For disk, does anyone remember the formula? Like the volume? Yep. We can just write R, you know. That's it. Because it's the area of a circle, pi r squared, times the thickness, dx. Now that's going to be whenever you go about any horizontal line. If it's the x-axis or y equals 7, this is the formula. It'll be dx. Each slice will have a thickness of dx. So anytime you go about a horizontal line, you're going to use pi times the integral of r squared dx. Now, if you're going about a vertical line, the y-axis or some other vertical line, and you take your have your disk there. What's the formula going to be for those? It's still going to be r squared, but now it'll be c to d because we're going to go smallest y to greatest y. And then it's not dx, it's dy. So if you go about the y-axis or any other vertical line, it's dy. And, to get r, it's always going to be the distance from the axis of rotation to the outside of the shaded region. So you'd be doing a y top minus y bottom over here. You'd be doing an x right minus x left over there. Okay, well, sometimes the region is not attached to the axis of rotation, so each slice is a washer. Anyone remember the washer method? Big R minus little r. Oh, now together or separately? Separately. I was just checking. And then if it's about we'll keep the horizontal line over here. So if each slice is a washer, and you about the x-axis, it's dx. So my limits of integration will be smallest x to greatest x, a to b. If we're going about some vertical line, and we're revolving some region that's not attached, each slice, don't square them together. Don't ever. Like, it's not the same. It has to be big R squared minus little r squared. Oh, yeah. I don't know why the line went over here. I messed that up. So now, what is the formula for washers when we're going about a vertical line? I'm asking. And then what did you say for the differential? Nice. So that means everything's going to be in terms of y when you go about any vertical line. Okay. So if they say that you're revolving a region about a line, it's either disk or washers. But now you got these other solids where every slice is a particular shape. They'll say every slice perpendicular to the x-axis or y-axis. That was cool, right? That one still worked for some reason. I don't know why. You have to, for those types, don't just throw pies in, okay? I don't know why people like to throw pies in. You just have to know that if you want to get the volume of that type of solid, where every slice is a particular shape, you integrate, you add up the area of that shape times its thickness. which is either going to be dx or dy. I should fill in the limits of integration. So this would be a to b if it's dx, and this would be c to d. Now, once you do that, so they say every slice perpendicular to the x-axis is a whatchamacallit. You write down, if it's x-axis, this first one, the dx. So you're still going to have to know the area formula for that shape. Let's see if we remember any of them. Semicircle in terms of the diameter, because I'm like, pi over 8d squared. What? Where did you get that from? I don't remember doing that. Yep, that's what it is. Just gotta believe me. First square, forget that. Who knows that? Don't ask me that one. You know the area of square, do you, kids? Something about it. Something about delicious. S. Okay. Squared. Oh, what a coincidence that is. All right, so it's the length of the side squared. All right, we got 2. It's bugging me. That's like that. Now, isosceles right triangle, that was a tough one because we actually have 2 formulas depending upon if it has to be in terms of the leg. Something. I don't know. Where is that? Okay. The isosceles right triangle, it's either going to be in terms of the leg. All right, people make fun of my L's, so I'm going to draw it like that. I tried to do a script one. Thanks, kids. You're just nice. And we call the hypotenuse H. Yeah, you know what? I think we called the hypotenuse H, so change this S. I don't know where it is on your paper. Well, let's call the hypotenuse H. That makes... Okay, so there's 2 formulas, and we know either of them. It is H squared over 4. You got the tough one. It's 1/4 the hypotenuse squared. I'm going to write it like that because we'd pull the 4th out. 1/2 leg squared. Like the 1/2 leg squared, I think you could always get because you think 1/2 base times height, so 1/2 leg squared. That would make sense. The other one, you have to. It takes a little more time to show where it comes from. Look back if you care. Yeah, and the way you would know which one to use, it depends on which side is lying in the base of the solid. If they said with every slice perpendicular to the x-axis with the leg in the plane of the base of the solid, then you use the leg one. But they have to indicate which side is is the one you can measure, the one that's in the base. And one more, equilateral triangle. Yeah, you think you know this one? Radical 3 over 4 times the side squared. Area, you're always going to have 2 dimensions of length, so you know. Okay, so here's the way those work. So whenever you have to get the volume of one of these solids, you write down, you are integrating area, either dx or dy, depending upon which way it's going. You fill in your area formula, right? Any one of these. You pull out the constant. And then, oh no, how are you going to get the L, the H, the S, the whatever? How are you going to get those lengths? Now, if it's a dx problem, that length, whether it's the leg, the hypotenuse, the side, the diameter, it's going to be y top minus y bottom. Whichever one of these you have, the length, for if it's dx, it's going to be y top minus y bottom for that. If it's a dy problem, and you have to get the diameter, what are you going to do to get it? Keep going. You just ran out of batteries. X right minus X left. Okay, yeah, don't leave me hanging like that. Yeah, that's good. That's it. Okay, so let's first go over these homework problems. So we might actually have time to start one of the area volume problems. That's so exciting. It is. Okay. I really need this out of my way. It's okay. All right, the first homework problem. Yeah. 2013 number 1. You know what I thought was a little tricky with this? they threw the units in like away from the function. I thought that was like a little sneaky. They said the rate in tons per hour that unprocessed gravel arrives is given by G of T. So that was your rate in, which you immediately put in Y1. Right? Then the rate out, if you didn't notice it was rate out, the gravel is being processed at a rate of 100 tons per hour. So your rate out, you put in Y2, that's 100. And I like to put into Y3 the rate of change, which is rate in minus rate out. We're like getting ourselves set up for this problem. See it? All right, and they did tell us at the beginning of the day there's 500 tons. We'll need that later. Okay. First question, they said find G prime of 5. All right, we got our calculator. So we just use n deriv. We put G in Y1. We get our answer. And as far as the units go, what do you do to get the units of a derivative? Multiply or divide. You got two choices. Divide, because this is dg dt. So you take the units of G, tons per hour, and you put them over the units of time, hours. That's why it's tons per hour squared. And you get a negative number, that's okay. That just means the rate G is decreasing at t equals 5. All right, so they're looking for the answer here, and you might not have said it the exact same way they said it. This wasn't worth a lot. All right, but if you, so that's the rate at which our rate is decreasing. All right, part B. This is another nice one. This was a good one, right? Straightforward. Find the total amount of gravel that arrives from time 0 to time 8. All right, so this is the only work we have to show, that we know we integrate the rate at which it arrives. But to get the answer, we just use math 9. We get that, right? Questions on that one? And the units, you know, they didn't ask us here, would be tons, because when you integrate, you multiply units. What's next? What's next? I can't see. Okay, there. See? Wait, you don't understand why we had to subtract 100? For this one? Oh, they're saying, no, you do that. Yeah. Yeah, Y2, yeah, is the 100, the rate out. So it is Y2 of 5. It just said that's 100. Yeah. Did you have your hand up? Someone else have their hand up? Yeah. Oh, sorry. I wasn't getting that. Jillian just said she liked my outfit. Because the first derivative at 5. Okay, but here's the thing. Okay, a lot of people made this mistake. They're like, oh, I already found G prime was negative in part A. But that was the derivative of G was negative. Remember, G itself is a derivative. If you want to know if the amount of anything is increasing or decreasing, find out if its derivative, which is rate in minus rate out, is positive or negative. That's the derivative of our rate in. So that wasn't the thing. So we just have to figure out, is rate in minus rate out at time 5 positive or negative? And it's negative. So that means that, and I did that on my calculator. Pretty good, huh? That was fast, right? Because I put the rate in. That's the rate of change, the rate in minus rate out. I just did that. So yeah, it's negative. Or you could have said G of 5 is, what was it? It was less than 100, so it's less than the rate out, so it's decreasing. I mean, there are other ways to word it. But as long as that rate in minus rate out is negative, the amount of whatever is decreasing. Okay? Okay. D. What is the maximum amount of unprocessed gravel at the plant during the workday? Okay, and I know in the answer key they didn't make a big deal about the whole justification. This one's only 3 points. Usually these are 5 or 6, but still I want to keep the good habits. Whenever you have to find an absolute max or min, please state that the max or min, whatever they're asking, can occur at an endpoint or when the derivative, which is in this case rate in minus rate out, g of t minus 100, is changing from positive to negative. Yeah, we're at a relative max, yeah. Yeah, I think so. I think that would be okay, but I almost want to relate it back to these. Like, what if they're thinking, oh, does he really know where? Well, I guess if you get it right, then that's true. Yeah. I'd feel better if you said when whatever the derivative is changes from positive to negative, but I think that would be okay. So we have to get the y coordinate at the endpoints, and when rate in minus rate out changes from positive to negative. Oh no, where is that? Look how I found it. There are different ways to get this. But if you just deselect the y1 and the y2 so you don't see them, just highlight their equal signs, you hit enter so they're not highlighted. So you can just graph rate in minus rate out on an interval from like 0 to 8. You can actually see where rate in minus rate out is going from positive to negative and use the 0 feature in your calc menu to get that time, which is like 4.923. So that would be where you could have, that's where you have your relative max, right? And then you just got to find the values of the function at each of those. So they told you at time 0 the amount, and you can say the amount of gravel. You can actually write it out up there if you don't know what to call it. At time 0 is 500. To find out how much gravel you have at any other time, use the 500 plus the definite integral of rate in minus rate out. So it's kind of small down here, but I'm showing you, like, on my calculator I could do it. 500 plus math 9 of y3, that's my rate in minus rate out, from 0 to 8. That's the 525. That's over here. They can't see when I point. And then for the other one, 500 plus math 9, the integral from 0 to this number. I should have stored it in A. And then always check the words, make sure you're answering the question. They didn't want the time, or did they want the time? They wanted the maximum amount, so that you actually give I always give them both anyway. So the maximum amount will be the 635. Any questions, Salman? Okay. 2014, like grass clippings. This was not a rate, but they're still giving you, and then we get into rates. They give you an equation that tells you, what was this, in tons? I forgot. No, in pounds. That'd be a lot of grass clippings. All right, A of T is measured in pounds, and it tells you the amount of grass clippings. So I put A of T in Y1 right away. First thing, we want average rate of change of A of T. Average rate of change. You got to know that that's the slope formula. Okay? Don't get them confused. Average value. And to do this on your calculator, you could just do in parentheses y1 of 30 minus y1 of 0 and divide that by 30. If you have A stored in y1, why not? Questions on that one? I think you guys got these. The second one, find the value of A prime of 15. Okay, so to get that, that's easy enough because we're just doing n deriv. We've got the function stored in y1 at time 15. Now, as far as units go, remember for units for a derivative, what do? Multiply or divide for derivatives. Divide, right? Units of A over units of time. So where are the units? Using correct units. Oh, I thought I copied this from answer key. Okay, so it's going to be pounds per, what was time measured in? Oh, days. Wasn't A just measured in pounds, and then so time would be measured in days, so pounds per day. You know what? Because technically you're allowed to either just cut it or round to 3 places. I always say round, but if you cut it and just truncate the rest of it, you can do that too. Okay, so you're finding the rate at which the amount of clippings is changing. And because it came out to be negative, it's the amount of grass clippings at day 15 is decreasing at a rate of this many pounds per day. That's your rate. All right, boring the kids. I got to move on. This was the tough problem. I got to say, part C. Find the time for which the amount of grass clippings, so that's A of t, is equal to, so where A of t is equal to the average amount of grass clippings in the bag from 0 to 30. So this is the equation we have to solve. We're trying to solve for t, where A of t equals that. Now, I have to say, I did it a slow way. I think it would have been better if you got this number first. You did, and it was 2.7. I would have put that in y2 instead of doing this whole thing. You solved it algebraically? Nice. Solve any equation, you put one side in y1, that's your A of t, and then put the other side in y2. And just get where they intersect. Hey, Alex, did all that? So this was very slow for some reason on my calculator. I was having some problems last night, but I think if you just put that in one side, that in the other side, get where they intersect. Where they intersect is where they're equal. Alright, so that would be the time. But yeah, if you could solve it with logs and all that, that's wonderful. Okay. And then the last question. Okay, this also had a little twist to it. First of all, guys, whenever you see linear approximation to A at t equals 30, or some linear approximation to some function at a particular value, write the equation of the tangent line. So we want to write the equation of the tangent line to A at t equals 30. And we're going to use that instead of the other function, g of t. So to get the y1, you're going to plug 30 into A. To get the slope, you plug 30 into A prime. Now I use y's and x's. Then you can move this term to the other side to get solved for y. If you want to, you don't have to. But this was the only thing that was a little tricky. They said find a time where the amount of grass clippings is 0.5. Approximate the time. So we're trying to approximate the x that makes y 0.5. Usually with these problems, we plug in a value for x, and then we get the y. This one was vice versa. But yeah, you know, these values I just got right from the calculator. And once you have that, you can solve it either algebraically, or you can just graph both sides. I think this would be easier just to solve algebraically. And you get your answer of t equals 35.054. Okay. All right, now, tonight's, or this weekend's, homework on area and volume. I just need you guys to take a look at those problems for a second. Yes. Area of a washer? Okay, using the washer method. Yeah. So, I'm just wondering, you didn't, like, your limits of integration are in the right order? For big R, you took the distance from the axis of rotation to the outer function. I hope you, and then squared it. It's always the, yeah, the axis you're revolving it about. Okay, try it that way. Guys, there are 2 problems with the calculator, and then there's 1 problem without the calculator. And that was only, what, a couple years ago, 2013? But really, like on that first part, because you have to integrate y top minus y bottom, you can, I know that if I just gave you the integral of, if it was all by itself, 1, 4, 5, yes, you can. This is a quick EU sub. This is one of those use sub quickies. What would you need? Oh, come on. What would you need for your DU over here? Thank you for not giving up, Audrey. All right, now, so if you need to put a 1/4 pie in there, what do you have to put on the outside? Like, you know what? I'll write it as pie over. Oh, and in this problem, there was a 4 I had to pull out already. Okay, so then, there you go. Really? We can't integrate that? I think we can. So it's 16 over pi. What would we get if you integrate cosine of u if you have du? We would just give up. Look at that. That really wasn't, that's just a little u subby. I know it looks crazy because of the pies and the fractions, like two of our favorites. But it is, yeah. No, because you're always going to have limits of integration. It'll always be a definite integral, so you don't need any plus c. And I bet that one with the no calculator, I'm not sure, I didn't look at it just recently. Did it have for the other parts do not evaluate, just set up the integral? No. So, really, if you can get past this part of the first part for the area, the other parts are easy. All right.